So Gartner says we will fail while creating our web applications or our containers and pushing them to the cloud. And it will be our fault. But is this true? Should this work, or is this a mistake? Like every other good idea or good like every other big mistake, everything starts with a very good idea. And I will like to take you on a journey with me, going through the steps, splitting our monolithic application into smaller pieces, and find out how secure can we make it. Let's see. And I want to imagine that you're at the beach. I know it's very hard nowadays to imagine that, but imagine you're at the beach and you're surfing the best waves and biggest waves there are. You're having the time of your life. And of course, you're using like small little cameras on you to capture this moment, as well as your friends have phones to capture this. But I was thinking some years ago, okay, how can we make an application to share it? Because terabytes and gigabytes of data now on the different devices, and how can you share this information or these clips with other people? So let's imagine we creating an application and you're able to upload your stuff to a server, of course, and then you bring your crowd again to a website, and then they cut out their little 5 seconds of fame. Wouldn't that be great? So you create the clips from the raw footage, and everyone is able to get their own clip. And then you, of course, can transfer this information into your favorite application like Instagram. And as soon as you do that, you all can enjoy how you serve your 5 minutes of fame, and you can like enjoy your dopamine levels inside your brain as you get thousands and thousands of likes. So this is our beauty. So I created a little application, and this was my to my abilities the best way I can come up with. And this was the application on the right side to upload your stuff, and then you can pick your little raw footages. So you upload the stuff, and then you can pick it, and then inside your browser you can scroll through the image or the video. You stream it, and then you set your cut marks, your 5 minutes of fame, and this get then cut into little pieces. And as those pieces are done, then you can enjoy them and upload them wherever. So this was the main idea, how we approach this problem. Of course, this is not easy, because in the background there is happening a lot of stuff. Of course, you need something to work or to run your web application. So you need a web server, and in the background, it's not only the web server, it's also the program that's hosting it. And of course, as you upload your stuff, you need some storage, like the storage on disk. And then, of course, you need to cut or to transcode all the videos into the resulting clips. All right. So this was kind of nice, and we built it quite fast. But this also posed some problems in the long run, because as this system got more attention, the load on the server was quite huge. So you're dealing a lot with the problem that you have to get a bigger and bigger server. Excuse me. And then this server is quite costly because you have a huge metal that you're buying or you're renting every month. And then, of course, sometimes it's a lot of load in there, and sometimes it's quite little. So you have a lot of idling power lying around. So what I think, by changing this monolith to a microservice, it would be great that this microservice could like scale up and down in order to like manage this idling power or to reduce the idling cost. All right, so this was one way. How can we or what is the purpose of the microservice? Also, I want to add one problem, because as you cut all the stuff, the utilization of the hardware is quite high. As you can imagine, converting videos is quite costly. So you need something that is distributed. And that was also quite a huge problem at this monolith, because every time you cut an image, or you create a preview of an image, or you cut a piece out, of course, this power is quite huge, and therefore the people are waiting a long time. So it would be great to distribute this task, and this wasn't really easy by having this huge monolith, right? And I would also like to add one purpose of microservices, because I would like to have reliability. As you can think, as I have only one server with one folder, it's quite tedious, because one time this folder gets crashed or deleted, or maybe the disk is full, then it's not very reliable, right? So you have to find a way to distribute that as well. Let's break it down. Let's break it down into parts. So we usually have front, we just carve that piece out of the monolith. We also have something that is an API, or like a backend, to receive all the requests from the API. And we would like to have a broker that queues our jobs. So if I want to add a cut on a specific mark, I have to add this job to the queue, and then it gets picked up by the cutting component, and that cuts it into pieces or transcodes a video file, and all is stored within an S3 AWS bucket. So that's the idea, to like split it up into several components. And of course, this also poses some problems, or some like to say, that adds complexity, because now not only one big chunk of code has to talk to him or herself. Also, you have to find those dependencies between the microservices. And of course, you find a way how the people can upload the stuff, for example, to the S3. And you find a way to like talk to the API. And also in the back end, there's a lot of interaction going on, because the API wants to like do the job handling, and of course the cutting stuff has to get the files from the S3 bucket. So there's a lot of stuff going on in the background. And the first challenge, as we deal with microservices, is of course to containerize the application parts or your components. So let's dig into that. I just thought, okay, let's containerize. Let's pull up Docker Podman, name your tool of choice, and create an image for that. And quite easily then I created an image. And as I am a security like interested person, I also ran it through scanners. And immediately I found out, okay, oh no, even at the first step, I had the problem that many of the components inside an official image had security problems. And of course, this is nowadays something we have to deal with, because as we look at some of the surveys in the past and also some recent surveys, it more or less says or gives the same big picture. All of those images, official images or just clones of images, do have security problems and do have supply chain problems. So every image is composed of many other dependencies, and this dependency hell is still one major problem in this domain. Keep this in mind, but okay, maybe in the first place, we don't need any, like, okay, what should the attacker do, right? So should he or she attack the libc of an image? Maybe we think that's not feasible in the first place. So let's go further. Let's say we want to run things. We want to do it live. So let's talk about trust boundaries and how the components work. And as we have a look at that, we can immediately see that there is one part that is more front-endish and one part that is more back-endish, right? Or components that are more on the back-end side of things. So we see that maybe we want to have this whole web stuff going on, right? So we have this user authenticating somewhere and then issuing the cat command, fine. But of course, we have some components that have no public access. So this RabbitMQ, for example, this message broker between the API and the cutting stuff is, of course, like hidden from the user. But also we have to deal with the idea that, okay, S3 is a whole other problem, because of course it's a system that we don't have access to, and we have to hide it behind maybe a CDN, a content delivery network, to provide our stuff. And as we look at this big picture, we can immediately pull out our like Excel sheets or open office sheets and write down some security problems immediately, right? So we can say maybe somebody is able to exploit a problem or a security bug inside this transcoding part. But we said, okay, maybe skip that. We have containers. Let's skip that problem for the first 5 minutes, and let's go to the more interesting problems, namely the uploading, or attackers uploading lots of stuff to the S3 and using this part or this service as their delivery network for their own applications. So they use your system maybe to host their own stuff for free. It's free for them. It's not free for you, right? So maybe you want to mitigate that and add some very smart choices like authorization, and maybe you want to type check some stuff. Let's dig into this problem domain in more detail. And the first, it's still the second challenge, is the authentication and authorization part, right? So you want to find out who is that, and is he able to upload something, to cut something, to send it to a friend, and so on. So you have to identify your users from the internet. And as we have a quick look on the chart or on our model, we immediately see that there also, of course, the problem domain of this. Okay, you have the front end and the backend API, and you have to authenticate and authorize the requests. Of course, this we usually know, but what about the S3 part, right? What about the Amazon part? How can we access the files there, and how can we share the files, and how can we upload it securely, because we don't have a lot of control over this on these subsystems. So for the web part, let's skip over that quite quick. I would say, okay, let's go with web tokens. It has some benefits. It has some downsides. Let's say, okay, that's the way of choice for the front-end and backend API. But what about S3? How can we solve the S3 part? And namely, we have to find a way, how can we say, I would like to have my users to upload stuff. Are they also allowed to download or stream the same document or the same object they upload? Or do we have to check it beforehand? And how complex is that? Also, how much complexity and code do we add to find a solution to that problem? Sometimes we also have to deal with the level of complexity we add as we go, right? So let's have a look at this particular problem, because we have our API, of course, that can prepare an object, but how can we make our users access this particular file? And usually we don't want to use the old stuff of AWS security again. So we don't want to have those access control lists in place, and we don't want to have public access to this particular bucket, so to speak. But what we could do is to create a bucket policy. And what a bucket policy is it's like a small document that describes what can be done using a specific user to do on a specific path inside this particular bucket. And we can see that here, right? We can see that we say here, okay, there's a principal called this with this identification string, and we say, okay, this one is able to do a get object. So he or she is able, or this identity is able to pull this file down. And this is exactly what we need as we, for example, use processing stuff or to just get a file to make a decision, yes or no, is this okay? And of course, we have to do some more complex stuff like, okay, maybe we want our cutting tool be able to read inside this upload part. So we have maybe a folder for uploading stuff, and then it gets checked, and then I can move it into a public folder that's accessible by a user. And the same goes with, for example, thumbnails. And as you maybe immediately point out, as you're proficient with dealing with maybe bucket policies, I already made a mistake here, right? Or I already made some could be improved parts here. I share here the get and put object, like the getting or streaming the video part, and also to upload it to the cloud with all the different folders. So what could be improved here is, of course, splitting this scheme. And as you go with it, you will find every time more and more details what you can improve. But this is one of the not solutions, but ways to control your access to this system. Of course, this has one problem. It says maybe you allows all of the users to get the file, like just to stream the video or to get the preview. This poses a problem because sometimes you don't have it identified inside WS, right? So you can't really use the JSON Web Token in the first place, or not in this scheme of not in this scheme of bucket policies. So maybe we find another way to solve this problem. We could say maybe we want to use the bucket policy, because as we create a policy like this, we see, okay, maybe somebody can upload it, but he or she can't download it. With the use of signed URLs, we can make like an exception for a specific time frame. And that's kind of nice because we can say, okay, for this particular file here, we have this upload API WBDH file and request. You can access this particular file. We can even say with this pre-signed URL, you can only get a file or we can push the file. This is quite nice, but it poses also another problem. So you have to juggle your your up and down sides here. You immediately see there is no user, so you have no authorized user here. It's still just an anonymous request from the web. And another like interesting side here is these URLs are created using your internal keys to access, for example, the bucket. So there are keys residing in the AWS, and you also can download them and you can use them in your containers. And those keys are used to create especially requests. So as we way as an attacker to gain this key, we can offline create URLs like this and gain access to files without any other help. So like, okay, we solved something, but still something is on the table. And as we talk about this, okay, we have these keys and how can we manage it? We have, of course, to distribute it inside your containers, right? So we have to find the containers where you really need the specific, for example, S3 access keys. We have to find the containers which are able to access the message queuing, and maybe that check your JWTs, right? So you distribute your access keys that, for example, in Kubernetes, you can, of course, but it's inside your system. And what we didn't tackle, and that will be one of the last challenges, is how can we control which input gets stick into your bucket? Because we just we're talking about how can we identify our people, or how can we just authorize our people, but we didn't say what are they allowed to add. And of course, this also applies to all the other components. As we have a front end, maybe your attacker wants to or to inject code inside the JavaScript of your application or inside the DOM and use the good old web attacks. But also your API could be attacked and to forge a server-side request forgery. And I would like to focus here on the S3 parts, because again, here we don't have full control over the system. And how can we like find out the valid and invalid files? Because sometimes attackers find a way to push up your HTML files, and then they are able to like host their application inside your infrastructure. All right, so how can we do this? I took one way to solve that. I took the way of creating a Lambda function to check every time something gets uploaded to a bucket. Then the bucket could trigger a Lambda function. What is a Lambda function? It's a very, very small container, and it gets like triggered as you upload your stuff. Then the AWS spins up a small little container, pulls code what you provided, which contains the checking code, for example, in my example, and then checks, okay, is this a good file or a bad file? And of course, then it can be moved to a more secure place, or to a, like, okay, this is a checked file place, and then can be shared. This also has some good parts and bad parts. Of course, the more complexity you add inside this checking function, the harder it is to implement the whole stuff and to control the complexity within the system. But of course, you have to deal with problems like that. Why this is interesting? What's the problem with a video file inside a inside this system? Well, of course, you have to think about, is there maybe a vulnerability inside this transcoding part? We have this cutter, right? So the thing that cuts your file, and inside here there could be a vulnerability that can be triggered. For example, by parsing the file itself, by transcoding it, by like streaming it. It's quite hard to like have no vulnerability in such complex software. Some are exploitable, some are not that relevant in our scenario. And indeed, there is a vulnerability that is quite interesting. If you're interested, you could watch the analysis of Live Overflow. He and Paul Jarrett had a look at a vulnerability that was identified by fuzzing FFmpeg. And of course, they found a way to like exploit it. They found a way how they got code execution on this part. And this is now the question is this a problem, or is this a disaster? And looking back at our threat model, we have to look inside the pod, the container, which is hosting our FFmpeg, right? Our cutter. And this could indeed be a problem from a threat model point of view, because as you or maybe all know, as you start a container, it has to have some access to the secrets inside the container, right? Because of course, the container needs to read the secret, and sometimes it's in the environment, and sometimes it's presented as a file. There are, of course, some possibilities to mitigate the risk or the like access, but still, in the end, you will gain access to it. So, what problems does this pose? Of course, we have maybe then access to the S3 because there is the access key residing inside the container. We maybe have access to the message queue because we have the password for the message queue. And in many cases, or it's intended that inside a Kubernetes cluster, they all have access inside the network. So you could maybe download all the video files from all your users as you gain access to just one container, or you can add a job to the message queue parsing the whole or the same file by the other containers, and again attack it or to gain control over the other containers as well. So a small little problem could lead to a disaster inside your system. This sometimes also applies to your backend infrastructure. As you all know, maybe you're hosting this in a Kubernetes cluster, and sometimes there are keys that can be used. Nowadays, it's getting less and less like possible. Please ask the With Us guys. They can tell you a lot of stuff about this. But sometimes you can gain control over part of the infrastructure as well. So what could be added to our mitigation approach in our threat model? Of course, we could improve the integrity of our container, which is the first line here. We could add, for example, seccomp, this controlling what the container is possible to do. And I encourage you to watch the talk later from the With Us guys. Also here, a big thanks that they helped compiling some of the parts of this talk. And here we could improve some stuff, of course, that could lead or could pose a big step up on security. Still, we have some residing risk. That's always the case. But in this case, we know what's the residing risk because we had a look at it. Okay, to summarize, what's better? Is it better to have a monolith or is it better to have a microservice? Did all the different changes improve the system a lot? I would say yes, because in a monolith, always, and we know this as penetration testers, as you attack a monolith and you gain control over one part, it's more or less game over for the whole system because the growth of privileges within a monolith is always quite fast. In microservices, from a security standpoint, it's much more complex to jump than from one system to another. And also, it's easier to tackle one part on at a time. Sometimes on monolith, applications, it's very right. I think, yes, we will be all and we should that should be the bottom line here. But what's interesting or what's important here is we all should employ the discussion: how can a system be attacked and what are the real threats and what are risks that should be accepted and what are risks that should be tackled. And that's the whole thing of this conference. So as we are all at the sec4dev, we all talk about development and security under one big conference, and that's the whole part of this talk. So thank you, enjoy your conference, and have a nice afternoon.
Thank you, Reinhard, for this awesome talk. One question, or the last, you said you're going to repeat the bottom line of your talk. Parts of this were not visible because I think there was just a connection problem in that very moment. So could you take maybe a minute to repeat the bottom line, because I think that's the most important part of this talk, of the end of this talk. So please repeat that last part.
So it's always fine that the connection kills itself if it's most important. So as for sec4dev, we want to contribute, right? Right? We want to talk about what our development standpoints, what are security solutions for a problem, and together we want to solve this big problem, right? And
that's the spirit. Yes,
that's the spirit here.
Mm-hmm. Okay.
I'm going to ask the first question.
Go ahead.
We got a handful of questions. So, can AI help in security in cloud?
Can you repeat that, please? Can I what?
Can AI?
Artificial intelligence help.
Thank you.
In which part, right? If you're referring to some specific project or area, I would be happy to discuss more. But on a broad scale, it's very hard to pinpoint one area of how AI tackles cloud issues.
Yeah, so this will go out to the person who asked this question. Maybe that person can rephrase the question and say, can it help with maybe one specific problem or what area they're referring to?
What could be one like phrase of this or area of this question is AI is, for example, employed in a lot of log analysis and threat detection parts, and the manual parts, of course, are quite tedious. And here, I think automation and AI helped a lot.
Yeah. Okay, there is also, it's not a question, it's rather an answer. Will the talks be recorded? Yes, they are recorded, not related to this talk. The next question is related to this talk. It says here, could a slim Lambda function be of any help for solving the S3 authorization problem?
Yes, so there are several ways to approach this, I think, and Lambda is one of them. Also, the AWS people, they have this API gateways, and you also can, for example, check authorization information there. That's more or less built in for some very simple authentication schemes. But as we see, Lambda is employed in more and more areas, especially in the checking parts, because that were the weaker areas of this like S3, like quite slim architecture.
Oh, now we got a lot of questions. The next one is, when creating a new project, should one start with building a monolith or start with microservice directly?
I think it depends on your group. So as we see, the monolith is much more easy to maintain, right? So if you have a small group or just you and your friend, it's easier maybe to maintain something like this. But of course, sometimes you want to scale it or to distribute it, and then you should think about microservices, because then you have also the possibility to have separate teams for a specific area. Like in a little toy example, the cutting stuff, for example, there's a team, or the web application is a team.
Yeah, so I think that summarizes it really well, because what you say basically is that the question whether we should use microservices or something else is rather a people question rather than a technical question, or it's an organizational question rather than a purely technical question. Yeah, so the next question, the most upvoted one that's left is, don't microservices increase the attack surface compared to a monolithic approach?
In terms of you have more and more components that you have to manage, yes, absolutely. Because you have more dependency problems here, or dependency challenges to solve. You have now maybe 15 base images rather than one, and you have 16 dependent applications rather than 2. But you can like isolate it better. You can say maybe your cutter is not necessary to connect back to your to the internet or to a specific other microservice. So it's much more like controllable in terms of, if you have the resources to really manage it, okay, you draw the diagrams and code the stuff, then it can be pinned down better than a whole like big chunk of code.
I want to add something to this, because I'm more of a historic view on how this went from monolithic applications to microservices, we see that in the past, so 20 years ago, we're building monolithic applications, huge blocks of code that were all tied together and tightly coupled. Now people go to the other extreme and they try to cut down everything to the minimum amount of code within one repository as possible. And I do believe that we will be going back at least one step in the other direction again, just as we did in other things as well. Look at programming languages. Those that emerged first were really strictly and statically typed, and it was hard to get started with those languages. Then we went to the other extreme, like JavaScript, where nothing is typed at all. And then now we're going back to typed languages again, because we're seeing static analysis is easier with typed languages. They're more reliable, they're better testable, and so on. I personally do believe that we will be going back one step in the other direction and not cutting everything down to the latest extreme, unless you're working with a company that has 10,000 of people who are working on software, maybe on the same product, right?
So it's like finding the right middle, right?
Yeah,
Like
it's always about the middle
yeah.
ground in the end. And I think, we're going back and forth through the extremes here a bit. When it comes to microservice approaches.
I would
Next
take
question.
yes. How can one identify the security problems in a microservice architecture?
That's a very good question. I would like to spread it into several parts. I think the most important thing is to first look at the broad picture. So I'm really a fan of threat modeling. You also using like in-depth techniques like code reviews in very specific sections, and also then checking the different, or isolating the different parts, like, okay, there are images and their applications and their API endpoints and their requests, and then tackling them one by one, but not to the like extremist extent. So let's try to be pragmatic here and to find for your time box or your budget the best way to improve the situation, not to fully solve it. That will be impossible.
You had an approach to you had basically a little threat model in your slides for parts of that system. I found that particularly interesting because I feel like people have a hard time coming up with something like a threat model. How did you do it? Did you just use your experience of things and what usually goes wrong, and then you just wrote them down and tried to find countermeasures, or was it more of a systematic approach in your situation?
I tried to employ the show stack threat modeling, but with a more like hackerish approach. So every time I identified like a big block to solve or to investigate, I also tried my like hacking techniques or research to find out, okay, what are the real scenarios, not to be too like fuzzy about, okay, there's integrity attacked, and not to pinpoint one specific area. So I would like to do it on two sides, either to use the threat modeling on a like drawing approach, and also to do some in-depth looks and tests.
Yeah, by the way, Reinhard and me are hacker buddies, so we're working in the same pen testing team for those who don't know us. So yes, I think there's time for maybe one last question. I think this is the most important question in this whole meetup.
Yeah, of course. Yeah. No, you ask.
Okay. How's Boris Shellradder doing?
He's fine. He was busy lately, so maybe he needs a vacation. Yes, sure. And he's, he had a kids lately, right? So every time you pop a shell, he has kids, right?
Okay. So he spawned child processes.
Child processes.
Can you maybe share it, because
and you have to take care of it.
Some people don't know what we're talking about.
Yeah, just to do this not on a weird level. Last year I gave a talk about container stuff, and we invented this little red guy, the Boris Red Shell, and of course I wanted, as a sec4dev person, to invite him as well.
Yeah, it's the little
But
bad
he's
process
not
tries
that
to break
cool
out
like
and-
Olivia.
With this eyebrow.
Yeah, eyebrows.
Eyebrows.
All right.
Thank you.
Thank you very much, Reini, for being part of the sec4dev special meetup. And yeah, hope you will be joining the other sessions as well. Have a good day and see you soon.